Why can't we recycle plastic in the same way we do for metal? Melt it and remold it? Well, for one, polymers degrade when melted. So you can't just turn a PET water bottle into a new PET water bottle. It won't have the same properties anymore. You can use post-consumer recycled PET in something else, like a CPET microwave dinner tray. But even then you can't just use all of it. You can only use a small percentage of it. Edit, that something else can. In fact, be a new bottle. But it will almost certainly be mixed with virgin material and won't be 100% recycled. 2. You can't mix types of plastics. Which means that either consumers have to be exceptional at separating their types of plastic, by which I mean the cap and ring on your water bottle has to be separated since they're probably PP, while the bottle itself is PET, or we have to have people sort through garbage bags full of recycling to separate it. Which adds a hell of a lot to the cost. There's also the fact that most plastics have some additives in them, for one reason or another. And plastics with certain additives can't be mixed with others. 3. Any contaminants, adhesives from stickers, residue from food or drink, etc., have to be washed off to the point where they're as close to completely gone as possible. Which is basically impossible and also adds a ton of labor, again increasing the cost dramatically. This is also true for paper/cardboard. Stop recycling your greasy pizza boxes. They can't be recycled if there's food or grease stuck to them. Edit, this may not be true. I'm not sure my city explicitly says not to recycle pizza boxes with grease on them. But why MMV? Maybe someone with more experience in recycling or paper/cardboard can chime in on this one. 4. Not all plastics or thermoplastics. Thermosetting polymers cannot be melted down. They'll just burn up and release a ton of pollutants into the air. And obviously you can't mix thermoplastic polymers and thermosetting polymers. Plastic parts can be ground and reused, regrind, but options for doing so are limited. Plastic has a heat history. The more you melt and reheat plastic, the more it degrades. As the plastic degrades, you lose its physical properties. This means you have to use virgin material, no regrind, for many applications, such as automotive or medical parts. Regrind also can be more difficult to process, as it is more prone to part defects. Visible burns in the final product or brittleness would be a few examples. Regrind typically needs to be mixed with virgin material during processing to avoid these defects. The size of the regrind also matters. With virgin material, the plastic comes in little plastic pellets, all the same size. When these are melted down, they all melt at relatively the same time. With regrind you get bigger chunks and dust. The dust tends to burn while the bigger chunks may not melt evenly. There is equipment to remove dust and more evenly chop parts. But then there is now additional cost to reusing materials. Then you get into contamination issues. Typically when doing regrind you don't reuse consumer products. Instead you are taking the scrap at the plant and regrinding it there. Even keeping it at the plant level, the chances for contamination is high. If a part is dropped on the floor and picks up dirt, now it's in your regrind. There are many different types of plastic and each may require different processing temperatures. In many cases you cannot even mix different grades of the same material. I may have 5 different types of polypropylene at the plant, each with different fillers or additives that should not be mixed. This creates a logistical problem at the plant, because now you need 5 different grinders and 5 different storage containers for your materials. All it takes is one person putting the wrong part in the wrong bin or grinder, and now you have a lot of scrap. Not all plastic melts. Thermoplastic ones melt when heated. But thermosetting ones are made strong by complicated bonds that don't break down with heat. They will catch fire first. This is a partial answer. Naturally. And thermoplastics can usually be remolded a couple of times before the polymer chains degrade too far and the properties they were valued for, optical clarity, waterproof, become harder to achieve. Plastic recycling can be done with a few plastics, especially when you're changing form to a lower quality, like making bottles into plastic bags, but overall, it's a greenwashing scam that was put forth by the plastic companies to ensure their products would happily remain in production and everyone could feel great about it. Most of the plastics you use daily will not be recycled. Cannot be recycled. Even if you toss it in the green bin. Sorry. Plus, when you see made from recycled, it is usually a blend of reused and virgin for strength. Have you ever tried unbaking a pie? Had to scroll too far for an answer for a 5-year-old. I was going to suggest it's like turning a cookie into a brownie. Same or similar basic ingredients, but once made can't be unmade or changed. Li5 means friendly. Simplified and layperson accessible explanations, not responses aimed at literal 5-year-olds. Like metal. You can melt ice and freeze it in a different shape. Like plastic. You can't unfry and refry an egg. It's also difficult to separate the quail egg from the duck egg after stir-frying them together. This is not an exact comparison. But I guess it will do for a 5-year-old. Plastic is really quite complex on a molecular level. Metals are simple. I've been doing some backyard aluminum recycling, and I'm surprised how much I have to skim off and waste in the form of aluminum oxide with contaminants. If I had to guess, I'm only getting 75 to 80% of the original material back. This is a great question and one that more people should be asking. It starts with the fact that not all plastics are the same. There's all types that can't be mixed together. So first off, we need a better recycling system. For instance, one where you would get money for the plastic waste you turn in. Like you get money for metals you recycle. Another thing is that with metals, because of the price difference, it is neatly sorted. You'll get a lot more money for copper than for mild steel, for instance. Now, to be able to do this, we should get better at identifying plastics. You could start by learning how to identify the different types by looking at the recycling triangles. They should be on every plastic part you have, and they can help you ID the plastic. Now, you should also know that not all types of plastic are easily, or even cleanly recyclable. But for the ones that are, yes, we could melt them and remold them, but like you couldn't melt copper and steel together. You cannot melt HDPE and PA together. One way to think of plastic is like a weave of long fibers similar to a cloth, but much smaller. When it's originally made, it's quite strong because those fibers are so long and tangled together. Every time it gets recycled, those fibers get pulled apart and many get broken into smaller and smaller pieces. Eventually, those pieces of the original fibers are too small to weave together to hold a structure anymore, and we don't have great methods for decomposing them back into the original components to make fresh new plastic fibers or an eco-friendly byproduct. First, let's limit this to thermoplastics. That's a type of plastic that can be melted. HDPE, ABS, PLA, PET, nylon, polyester, polycarbonate, acrylic are some types you've probably heard of. A big part of the reason that metal is very forgiving when recycled is that the extremely high heat burns off contaminants. And most of what's left turns into slag that's easily skimmed off. It's also not a huge deal if a little bit of other metals/alloys are in the mix. Sure, that changes the alloy a little, but that's easily and quickly tested and can be addressed. Metals can be recycled over and over, and aluminum is often described as being indefinitely 100% recyclable. And nearly 75% of all aluminum ever made is still in use in either its original or recycled form. Plastic is tough to recycle because a minuscule amount of contaminant, including the wrong type of plastic, can irreparably ruin the entire batch. It's also tough to sort plastic. Bigger rigid items are much easier because automated systems can identify, Sort and clean them. Shreds and sheets of plastic are basically impossible, unless it comes from a manufacturing facility that already pre-sorts it. Yeah. They might be technically recyclable. But identifying, sorting and cleaning it from a mixed batch of recyclables is incredibly expensive. Like how to sort a polyester t-shirt. The fabric may be polyester, with cotton or nylon thread, a nylon tag, and possibly some screen printing or embroidery. Another problem is that the quality of plastic gets worse every time it's recycled, which limits its applications. The main idea is that plastic recycling is not a technological problem but an economic one. Either the technology to completely recycle plastic already exists, or if it does not, we can develop it. But plastic recycling is not economically feasible. The world works such that if there is money to be made out of it, it will get done even if it is selling children, or selling drugs to children. But since there is no money to be made, we as a country, or a species, are not doing it. Well, that's depressing. But then again, what isn't? Some plastics are like ramen noodles, overlapping each other and tangling up. But each noodle is distinct and separable. You might lose a lot of noodles by breaking them, but ultimately the end product is separated ramen noodles that you can remix together again. Keep doing this and eventually you don't have strands of noodle anymore, just bits and pieces. Other plastics are more like a sheet of lasagna, where everything is physically connected. You can't separate it then mix it back together like the ramen. It's just not the same thing anymore and would be more like fettuccine. These are called thermoplastic and thermosets, respectively. Some thermoplastic can sorta be melted then remolded. 3D printers basically do this. Another issue is impurities. Impurities can completely ruin a plastic molecule from forming or binding the way it should. Metal doesn't usually have as much of an issue with this, as the metal forms crystal structures rather than something like an amorphous structure. For ELI5, think random arrangement rather than orderly. It's like reheating and reusing oatmeal. If it was colored green and cinnamon flavor before, you can't take that out. Not only will the texture not be quite the same as before from reheating, but you've got to find a product that it would blend well with, say apple spice flavor, if your bottle is green. You can't make a white bottle out of it. And it won't be the same as the fresh plastic anyway. We recycle food package plastics here in Finland. Started a year or two ago. We got a separate color bin for them. Gotta wash and dry them first and check if they have PVC or 03/3 markings on them. And if not, they are good for the plastic bin. But that's the extent of my knowledge. Many do it. Once you get used to it, it's no bother. We already had separate bins for paper, cardboard, bio, metal, glass, etc. So it's just one more thing. Smiley face. In Sweden we recycle 1% of all PET bottles. You get between 1 to 4 kr per bottle, 1 to 0. For $, when you recycle them. There is sometimes a holder for cans and bottles at the side of trash cans, so it's easier for homeless people to collect them. Win-win. I'm a geologist and one of the places I commonly have to work is recycling facilities. All of the recycling that is put in the bins every week goes to a crusher, is dumped in the bed of a semi, and hauled to a landfill. Honestly, it's fairly disappointing because they're typically making a much bigger mess at the facility pretending to recycle than actually just throwing it in the dump. But whatever makes folks feel good about it, I guess. When I lived in Florida, we had a bin for recyclables and one for trash. When the garbage truck came, it took both bins and dumped them both in the back of the truck. But for some reason, even after knowing this, we still continued to sort our trash, to feel good about it, I guess. Come to think about it, I still do this too. We can. But every time you do that, the quality of the plastic drops. For much of the plastic waste we would recycle, it is not even worth doing it once. Plastic is a broad term for a lot of different materials. They have in common to be chains, but some are more knotted than others. If they are too knotted, you cannot disassemble them with heating. Much like you cannot loosen knots by just pulling on the ends. This type of plastic is called duraplasts. The only way to reuse it is to shred it into pieces and use the pieces for a different purpose. For example, in road building. Others, called thermoplasts, can be disassembled with heat because they are not as interwoven. But each time you heat it, you also cut some of the chains. And with shorter chains, it loses its functionality. And you can't reuse it if it's a mixture of different thermoplast, or if it is too dirty. Metal is more like water. You can freeze it and melt it as often as you wish, because you are not destroying anything in this process. Another example would be, plastic is like fabric. If you dislike your dress, you can cut and make something smaller. But you cannot make the same dress with it after you cut it. Metal is like Lego. You can build and disassemble it as often as you wish. Plastic is an umbrella term for two different families. Thermoset plastics form and cannot be reformed, they burn and become completely unusable. Thermoplastics can be melted and reused. Robots love sorting recycled materials. Working with 3 companies to increase picking efficiency above the 80-ish%. I was told this week that HDPE, think milk jugs, is fetching more money than aluminum. Even in these times of low oil prices. As a consumer, don't give up on recycling. There are a lot of very talented people working to solve this issue. When I was a kid, plastic was rare. We returned glass bottles or reused things. How about we go back to that? Get rid of as much consumer plastic as possible. There's lots of good answers, but I'll put this in 2. I work in a plastics manufacturing plant. We make plastic bags from mixes of low-density polyethylene and high-density polyethylene specifically. We want to use as much recycled plastic as possible, as this allows us to reuse our own scrap/waste. But in practice, as per you/Eric Panik's excellent post, plastic degrades when melted. We're basically limited to 5-10% by weight of recycled plastic. And this is, remember, exactly the same material. Before printing. Once the plastic is printed, it's basically unusable to us for recycling because the ink acts as a very inconsistent and low-quality dye. So, assume we've just got a tiny amount of simple black print, a bit of text, on clear plastic bags. Now if ground up and reused, that clear plastic is now smoky black plastic, but worse, because the plastic is degraded, and the impurities, ink, degrade it even further. So in practice, just how much you actually can recycle plastic is, as others have said, very limited. Broadly speaking, there's 2 types of plastics: thermoplastics and thermosets. Thermoplastics actually can be melted down and reshaped and recycled. However, thermosets are significantly better in just about every way. They're stronger, more heat resistant, experience less fatigue from stresses, etc. They're just the better material to make things with. And they're cheaper. But they can't be recycled. Never mind the BS. There is no money in it. So people can't get rich. Metals are worth money. Plastic is not. Tangential question: why ban plastic shopping bags? We use those shopping bags as our trash bags, which is what I assume everyone does. If we didn't have those shopping bags, we'd have to go out and buy trash bags anyway. And those are usually thicker plastic than shopping bags.